In this lecture, we'll talk about refrigerators. Earlier, we have talked about heat engines. So refrigerator can be seen as heat engines operating in reverse. Here is the schematic of energy flow diagram of a refrigerator. So just like heat engine, you have hot reservoir. This is your cold reservoir at temperature Tc, hot reservoir at temperature Th. And so here in the refrigerator, as we know, that heat is extracted from inside the refrigerator. So to do that, we do a work on the engine. So external work is done on the engine. So that's why direction of work is in the engine. So work is done on the engine to extract an energy of QL, amount QL or QC. I think we are using QC earlier. So it is taken QC from the cold reservoir and it is dumped in the hot side. So in the refrigerator, it's dumped outside. So we can see here that QC or magnitude of QC plus magnitude of work must be equal to magnitude of QH, right? Now here we defined a term denoted by K, and K is called coefficient of performance, or COP, performance of a refrigerator. All right, and this coefficient is defined by the K is what we want to the what we pay for. What we pay for, right? So what we want QC amount of energy to be extracted from. So we say QC, this is the amount we want to be coming out of from the inside of the refrigerator. And what we are paying for, we are paying for this work we are doing it. So that's the work we are doing it. Okay, and if you see QC remains there, so we can put it QC, magnitude of QC, and W we can see from here is nothing but the magnitude of QH minus magnitude of QC. Right, so this is an expression for K for coefficient of performance. So this is the formula. We can kind of make a box around the whole formula. All right, so that is important formula you need to understand. Remember, if this is a real refrigerator, what happens if this is an ideal refrigerator? That means we can say KC, and KC, C stands for Carnot refrigerator, Carnot. So if this is a Carnot refrigerator, it's an ideal refrigerator, then we have seen before that QC over QH was nothing but TC over TH, right? We have seen earlier when we were talking about Carnot cycle. So I can just replace all QC, QH with TC and TH. So I can say temperature of C, TC, and temperature H minus temperature C of the cold reservoir, right? So this is ideal. This is the, again, sets the limit, the maximum performance, coefficient performance you can get in an ideal refrigerator. Great.